Hello, I'm Skip Martins, Field Service Manager with Hendrickson Truck Suspension Systems. I would like to take this opportunity to review some of the key features and service points of the Hendrickson AIRTEK suspension. For complete information, please refer to our technical publication 17730-247. This publication is available on our website at www.hendrickson-intl.com or by contacting our Technical Services Department at area code 630-910-2800. The technical publication will give complete work instructions, torque specification, and as always, please adhere to the warnings and cautions for safe maintenance practices. The AIRTEK is available in two models. We have the 12,500 pound capacity and also the optional 13,200 to 14,600 pound model. During the development of the AIRTEK suspension, four key features were paramount: good roll stability, good ride quality, good handling features for the operator, and reduced maintenance. We met these key objectives with the design of the steel leaf spring and our air spring combination. As you can see, the front limb of the steel spring is quite thick and rigid. This couples to our clamp group, which offers four-sided clamping forces on the Hendrickson STEERTEK axle. The STEERTEK axle is a formed and robotically welded box section. It is hollow. This makes the axle torsionally rigid. This front system gives the AIRTEK good roll stability. Our ride quality is addressed with the combination of the air spring and the soft rate of the rear limb of this spring. Our air spring carries 80% of the load. The rear limb of the steel spring carries the remaining 20%. Our handling is accomplished through the convolute design of the steel spring. All road inputs pass through in a straight vertical motion, thus improving the handling characteristics of the suspension for the operator. Reduced maintenance of the AIRTEK suspension has been accomplished by the use of premium rubber bushings at all the major points, which require no lubrication. However, our STEERTEK axle still does require lubrication at the normal service points. If a vehicle equipped with a Hendrickson AIRTEK suspension becomes disabled on the road and requires towing, Hendrickson has three different methods preferred for towing. The first method is the wheel end lift. This is the easiest and safest method to use. Our second option is the axle fork lift. The axle fork method does require the use of specially designed forks. This specifications for this fork can be found in our technical publication. As you see, there is an offset. The long part of this offset does need to be oriented toward the front of the axle. The axle fork fits up under the lower axle wrap, which gives a good, safe towing point for the vehicle. The spring-eye method is our third option. Please refer to our technical publication for complete details. If a vehicle requires off-roadway movement, Hendrickson recommends the use of two nylon straps wrapped around the axle between the two clamp groups. Never use a chain on a STEERTEK axle. Use of a chain can cause damage to the axle beam. One of the key requirements to ensure good ride quality is maintaining the proper ride height. Should an operator notice a degradation in his ride quality, the first thing we want to do is check our ride height. Checking the ride height has been made easier with the development of two height gauges which are available from Hendrickson. The blue gauge is the one we use for our 12,500 pound capacity. The green gauge will be used for the 13,200, 14,600 pound model. Checking your ride height is quite an easy task. The first thing we'd like to do is to ensure that the brakes are released, chalk your wheels. Next step is to disconnect your leveling link and cycle your suspension. Once the suspension has raised back up, we want to verify the ride height by placing the gauge at the center of the bracket and pumping the bottom of the gauge to the bottom of the piston on the air spring. Ride height is controlled by a single leveling valve located on the left-hand side of the vehicle. Ride height adjustment is quite easy with the use of a 7/16 end wrench and a 3/16 Allen wrench. To do this, place the Allen wrench in the socket head cap screw at the base of the leveling valve. Loosen your 7/16 nut. Once these are loosened, you can adjust the ride height by rotating the valve counterclockwise or to the left to lift the suspension, or clockwise or to the right to reduce suspension height. Once your adjustment has been accomplished, retighten your fasteners, disconnect your leveling link, and recycle the suspension. Once the suspension has been aired up, re-verify your ride height with the use of the height gauge. This procedure may require multiple attempts, and you want to be sure that you always maintain full air pressure on the vehicle during this process. Should an air spring become damaged by road debris, replacement is an easy task to accomplish. Prior to any servicing, you want to ensure that all air has been deflated from the AIRTEK suspension system. The air springs are all fit with push lock connectors. The first thing we want to do is clean all the debris away from the push lock connector to prevent contamination of our air system. You refer to our technical publication for further details. Simply push down on the air line using a screwdriver, push on the outer collar, and remove the air line. Once the air line has been removed, take your screwdriver, place it between the hanger and the top of the air spring, and gently pry down to dislodge the spring. The bottom likewise has the same locator tab. Place a screwdriver between the lower piston and the top of the top pad and dislodge the lower air spring. This air spring is a one-piece design. It is equipped with an internal bump stop. Should deflate while it's on the road. It'll ride the bump stop safely to the closest service point. As with the air spring for the optional 13,200 to 14,600 pound capacity. As you can see, it is a larger diameter air spring. It uses standard industry stud mounting fastening and is also equipped with push connect fitting. This bag also has an internal bump stop. The 13,200 and 14,600 pound capacity air spring does require the use of an additional adapter. If you notice, the tab on the top of this adapter must be aligned with the notch in the top pad to allow for proper orientation of the air spring. Due to the offset positioning of the air spring, it is required to have an additional auxiliary bump stop placed in the center of the top pad to help support the vehicle. Next, I'd like to address the shock absorber. The AIRTEK system uses a premium shock absorber designed especially for the AIRTEK system. If a shock should require replacement, you do need to replace it with a genuine OEM part in order to maintain proper ride quality and also your warranty. If you suspect a shock being defective, there is a simple test that you can perform. It's called the heat test. We want to drive the vehicle around in normal fashion for 15 minutes. Bring the vehicle back into the service area. Take your hand and place it on the frame to get an ambient reference. Then carefully place your hand on the lower portion of the shock absorber. If the shock absorber feels warm to the touch, it is functioning properly. If the shock absorber feels cold to the touch, it's malfunctioning and will require replacement. Also, if you know some light misting of oil on the base of the shock absorber, this is a normal function of a shock. However, if there is a heavy film of oil on the lower portion of the shock, that's telling us that the shock is leaking and will require replacement. The shock is mounted to the vehicle with standard metric fasteners. And it's quite easy to replace. Let's take a look at the frame hangers. The front frame hanger is provided by Volvo. Please refer to your Volvo technical publications for service information. We have fit the Volvo hanger with special adapters to permit us to use the 20mm bolt for our spring eye connection. Due to interferences with the powertrain, it does require us to install the bolt from the outside in. Once the bolt is installed, ensure that the lock bolts are loosened. This will ensure a proper clamp on our spring eye connection. Once the clamp torque is completed, re-torque the pinch bolts. Please refer to our technical publication for the torque requirements. Now let's move back to the rear shackle bracket. The bracket is a directional aluminum casting which has been fit with a premium rubber bushing. This rubber bushing is designed to give extended service life. However, if a premature failure should occur, the entire hanger will have to be replaced as the bushing is not serviceable. Next we have the shackle assembly. As you can see by the profile, the shackle assembly is directional. The spacer bolt does need to be oriented toward the front of the vehicle. And as you see, like the front hanger, the shackle bolts need to be placed from the outboard side facing in and also need to be torqued through the bolt head. Please refer to our technical publication for the proper torque specification. Acting as an interface between the shackle bracket and the shackle assembly are thrust washers. The thrust washer material has been designed to give us extended life. However, we recommend that the thrust washers be replaced anytime the shackle plates are disassembled for service. Now that we have the frame section removed, let's focus on the clamp group. As you can see, this exclusive clamp group design has eliminated the need for U-bolts. We use 4 M20 fasteners with crimp nuts. If you should have to service this joint and cannot get one of the fasteners loose, do not use a torch. We recommend that you use a cutoff saw, go halfway through the shank of the bolt, and then fracture the remaining portion. Now that we have the clamp bolts removed, let's take a look at the top pad. The top top head is a directional casting and serves many functions. It is the upper locator for the clamp group bolts. It is the lower shock mount. It is the lower mount for the high control valve linkage and the lower mount for the air spring. As we had previously instructed, with the 13,200 and 14,600 pound capacity suspension, the use of an auxiliary adapter is required. The adapter, the tab of the adapter, needs to be located in the notch of the top pad to ensure proper orientation of the air spring. We also have the auxiliary bump stop. The rubber portion of the auxiliary bump stop is serviceable. If it should wear down to a dimension of a 1/16 of an inch, simply pry out the old rubber stop and replace with a new. Now let's focus on the spring. The front limb of the spring is the thick portion, which gives us our good roll stability. The rear limb is the thin convoluted section, which gives us our good ride quality. The front and rear spring eyes have premium rubber bushings installed, which are designed to give extended service life. However, if these bushings should see a premature failure, the entire spring leaf must be replaced as the bushings are not serviceable. The spring weighs 53 pounds and is quite easy for one technician to replace a spring. As you can see, the liner acts as an interface between the spring and the top pad. Due to the weight bias that is inherent on all vehicles to the left-hand side, we do require the use of a 12mm spacer to compensate for the weight bias. This will keep the vehicle level during normal operation. On some models, we will have a Z-spacer on both sides of the vehicle. Please refer to the technical publication for these applications. As you can see, it is an extruded Z shape. These little tabs help keep the spacer located during the assembly process. As you can see, we have a floating dowel. This dowel is used to locate all of the components of the clamp group in the proper orientation. Here we have the upper and lower axle wraps. As you can see, there is an interface between the two components. This interface helps to ensure equal clamp force around the axle beam. Now that we're getting ready to remove the lower axle wrap, in some cases this tight interface between the upper and lower connection will require the use of force to separate the two components. If force is required, Hendrickson recommends the use of a soft-faced mallet. This will prevent any damage to either component. Let's remove the lower axle wrap. As you can see, the lower axle wrap is a non-directional forging. It is also rotational. As part of the lower axle wrap, we have a Delrin axle wrap liner. This liner acts as an interface between the axle wrap and the bottom of the axle beam. Anytime the axle clamp group is serviced, it is recommended that the liner be replaced. Likewise, during the inspection of the suspension, if you should find a crack within the axle liner and there is no pieces missing, it does not need immediate attention. However, if you find a crack in the axle wrap liner and there is a portion of it missing, it will require immediate replacement. And here we have left the upper axle wrap. The upper axle wrap is an aluminum extrusion. If removal is required, again we suggest using a soft face mallet to prevent damage to the upper axle wrap. As with the lower, the upper axle wrap does use a Delrin liner. The same crack criteria applies for the upper axle wrap liner as the lower. Now that we have the wheel and brake assemblies removed from the axle, let's focus on the steering knuckle. The steering knuckle comes with two separate spindle designs. We have the 58mm straight spindle for use with the Volvo unitized hub, or we offer the standard taper spindle for use with the conventional oil bath preset hub assemblies. Please refer to the Volvo technical publications for specific work instructions on these items. As you can see, we have two socket head cap screws remaining in our knuckle assembly. Prior to removing the socket head cap screws, we want to place a wooden block under the base of the lower steering knuckle and support that with a bottle jack. This will prevent the lower steering knuckle from sliding off of the kingpin and damaging the part. Let's remove the socket head cap screws. Now that we have the socket head cap screws removed, we are ready to remove the lower steering knuckle. We'll want to save the two removed socket head cap screws to reuse during our checking of the vertical clearance of the steering knuckle assembly. Now that we have the lower section removed, now is a good time to address our 5 mounting bolt holes. The 5 mounting bolts all make use of Loctite to help maintain the connection. Anytime we service it, we want to go through and take a tap and run a tap through these 5 holes to remove any of the residual Loctite. Once this has been completed, we're ready to remove the upper connection. With the steering knuckle removed, our next task will be to remove the spacer shim. This is used for setting vertical clearance of the steering knuckle assembly. And finally, we will remove the thrust bearing. Once the spacer and the thrust bearing have been removed, we are ready to service the kingpin. As you can see, there are no draw keys on the kingpin. The kingpin for the STEERTEK axle is cryogenically frozen and pressed into the axle beam to form a permanent interface. When you remove a steering knuckle, if you should find a loose kingpin, this will require replacement of the axle beam. Our first step is to wipe off the grease from the kingpin. Once this is completed, we'll want to polish this kingpin with emery cloth of 240 grit or higher. We'll want to spray a little WD-40 or mineral spirits on our kingpin and use smooth, steady motion and ensure that we get equal polish around the entire surface of the kingpin. If you find scratches or dimple witness marks in the kingpin, these are normal and are not a reason for replacement of the axle beam assembly. Once our polishing is complete, we'll want to remove any of the residuals. We're now ready to check the size of our kingpin. Using a 1 to 2 inch micrometer, we'll want to take 4 separate readings of the kingpin. We'll take a reading at the top and at the base. Rotate the micrometer 90 degrees. Again, taking a measurement at the top and again at the base. The minimum tolerance for a Kingpin on a STEERTEK axle is 1.802 inches. Anything below that spec will require that the axle is replaced. We want to repeat these same steps on all 4 points of the Kingpins. Here we have a standard DX bearing service kit. What you will find included in the kit are 2 new DX bearings, 2 Kingpin seals, 2 new socket head cap screws with patch lock Loctite, 2 new grease caps, 2 retainer rings, spacer, bottle of Loctite, and a thrust bearing. As you can see, we have 2 different design thrust bearings. This is a steering enhancement feature of the STEERTEK axle. The right-hand side of the STEERTEK axle is equipped with a standard steel roller bearing style thrust bearing. The left-hand side is equipped with a composite style thrust bearing. This composite bearing dampens out inputs into the system. As we had previously mentioned, there are 2 different style thrust bearings on the STEERTEK axle. The right-hand thrust bearing is a standard steel roller style bearing. The bearing has what we see here as purge vents. To ensure proper performance of the steel roller bearing, during our lubrication maintenance cycle, we do need to ensure that we have grease purging from this vent. There are 4 vents equally spaced around the diameter of the bearing. We must ensure that we have equal purging in all 4 points. The left bearing is a composite configuration. This bearing does not have purge vents. As you can see, we have an upper and a lower shell. The interface between these 2 is where we will see the grease purge. Again, during our lubrication maintenance cycle, we do want to ensure that we have an even purge of grease around the entire circumference of the bearing. Now we're ready to service our steering knuckle assemblies. Our first process will be to remove the retainer ring from above the grease cap. Once this ring has been removed, we're able to remove our grease cap. And now we're ready to service the DX bearing. All servicing should be performed from the machine side of the steering knuckle when pressing in and pressing out the DX bearings. Now that we have the DX bearing installed, we want to ensure that that bearing is installed to a depth of 5/16 of an inch. Once that has been verified, we will be ready to ream the bearing to fit the Kingpin. Place the steering knuckle into a vise, lock it down. We want to recommend that you use brass jaws to prevent any marring and damage to the machine surfaces of the steering knuckle. Take the straight shank reamer and adjust it to a dimension of 1/1000th of an inch greater than the measured diameter of the Kingpin. Place it into the DX bearing. Rotate the reamer evenly, letting the weight of the reamer itself carry through the DX bearing. Once the reaming process has been complete, We want to remove the steering knuckle from the vise, and using a screwdriver, we want to go through and ensure that all of the residual material is clean from the grease screws in the DX bearing. Once the grease screws have been cleaned, we'll want to spray the bearing with some WD-40, wipe it out just to make sure that our surfaces are completely clean. After the bearing has been cleaned, our next procedure will be to install the Kingpin seal. The Kingpin seal does require proper orientation. We always want to ensure that the open side of the seal points up. Place the seal into the Kingpin bore. Using a seal driver, we want to set the seal flush with the machine's face of the Kingpin. Verify that the seal is set flush and proper. And now we're ready to install the upper steering knuckle onto the Kingpin. Once we have completed our sizing of the DX bearing and installation of the seal, we do want to place each of the steering knuckle halves on the pin in order to verify proper fit. Once the knuckle has been installed on the pin, we want to rotate from side to side, ensuring free, clean sweeps. I also want to check to make sure there is no binding and no excessive loose play. Once this has been verified, we're now ready to start the reassembly process. We're going to start our assembly process by placing our 47 thousandths spacer shim over the upper Kingpin and our thrust bearing on the lower Kingpin. Once this has been completed, we're now ready to install our steering knuckles. Start with the upper steering knuckle. And then install the lower. Now that we have the upper and lower steering knuckles assembled using the old socket head cap screws, we will also want to hand install the 3 upper mounting bolts for the brakes to help maintain proper alignment of the connection. Now we're ready to check the vertical clearance of the steering knuckle. To do this, we want to use a dial indicator, placing the base on the axle beam and the tip of the dial indicator on the top of the steering knuckle. We will place our dial indicator on the gooseneck, lock down our base. Once we have that established, we want to set our 0. Once our 0 has been established, we'll take our wooden block and bottle jack under the lower steering knuckle and raise the assembly up and verify our vertical end play. Vertical clearance specifications for the assembly are 8 to 11 thousandths. However, general maintenance specifications are 8 to 30 thousandths. Once that has been established, we can remove our dial indicator, and then one at a time replace our old socket head cap screws with the new ones that are provided in the kit that do contain patch lock Loctite. On the forward side of the STEERTEK axle beam, there is a warning placard. We do ask that you adhere strictly to the warnings on this placard. If a technician does require additional information on the STEERTEK axle, he can look on the top of the gooseneck beam. We do have a ID tag. The ID tag contains the serial number, axle number, and assembly number. This concludes our brief review of the features and service points of the Hendrickson AIRTEK system. Again, for complete instructions, please refer to our technical publication 17730-247 for complete work instructions, torque specifications, and warnings and cautions.